Hi dear students. So in the last class we have discussed about the current, then the potential, and some of the major equipments and its symbol or the representation that we have to follow in the circuit diagram. So today we will discuss about the Ohm's law. Actually, Ohm's law has been invented by the physicist George Simon Ohm. So that's why it is known as Ohm's law. It is named after the scientist who have invented the Ohm's law. Its name is George Simon Ohm. And he invented the Ohm's law in 1827 or introduced the Ohm's law in 1827. Actually, Ohm's law is giving as the relation between the potential difference between the terminals and the current flowing through a conductor. Okay, so the relation between V and I, the potential difference between the terminals of the conductors and the current which is flowing through that conductor, the relation which can be obtained by the Ohm's law. Okay, V and I. So it is given in the PPT. You can see that George Simon Ohm found the relationship between current I flowing to a metallic wire or a conductor and the potential difference across its terminals. Terminals means the end points. Actually, we have to suppose if we are considering one conductor, then we have to consider the terminal points. We have to consider the potential difference between the end points. Okay. Now, the statement of Ohm's law, it is given here. You have to study this one. Actually, this is one of the important topic, Ohm's law. Okay. So the statement is that the potential difference V across the ends of a given metallic wire, okay, the potential difference across the ends, that is the terminal points, okay, in an electric circuit is directly proportional to the current flowing through it. So the potential difference along the potential difference between the end points of the conductor is directly proportional to the current flowing through that conductor. Okay, directly proportional means whenever the V increases, I also increases. If I is increasing, V will be increasing as well. If I is decreasing, V will also be decreasing. That is, the relationship is actually linear. Okay, the linear relationship between the V and I. Okay, so and one condition is there, provided its temperature remains the same. So if the temperature is varying, then the Ohm's law will not be valid. Okay, so at constant temperature, the potential difference between the ends of the conductor, okay, and the current flowing through that conductor will be directly or proportional to each other. Okay, so that is the condition. So the constant temperature should be maintained. So that is the statement. Okay, now the mathematical representation of Ohm's law. Actually, we have already in the statement itself we have seen that the V is proportional to I when at a constant temperature. Okay, if the temperature is constant, then the V will be linearly proportional to the I. V is the potential difference between the ends of the conductor and I is the current which is passing through that conductor. That means if V proportional to I, then V by I will be a constant value. Okay, suppose you are varying the V and I values, so and you have noting down the I for some particular V values, and afterwards if you are taking the ratio, that is V by I, then all the values, all the V by I values will be a constant value only. Actually, that is the experiment that we are that is the experiment for the Ohm's law. For the proof of the Ohm's law, you are having an activity. You just go through that activity, okay, in the textbook, read that one. and if time allows we will do that one in the lab. Okay, so V by I is a constant, and that constant is known as R, that is the resistance. Okay, so we can say the V by I is equal to R, so V will be is equal to I into R. Okay, so the mathematical representation also you should study, that is V proportional to I. Then if V proportional to I, then V by I will be a constant, and that constant is known as R, that is the resistance of that conductor. Okay, so then V can be represented as V will be is equal to I into R. Some mathematical problems can be asked by using this equation, and some examples are given in the textbook itself. We will discuss that one. And let us come to that graph. Okay, so on the y-axis the potential difference V is given, and on the x-axis the current I, and the unit is given A, ampere. Okay, so you can see the relation between them, that is a linear graph it is, isn't it? That means as V increases, suppose for the first one 0.01, the V value is near about 0.3, then 0.2, sorry 0.1, the approximate V value it is 3. You can see at this marked point. Okay, 0.3, then 0.2, if you are looking for the 0.2, if the current value is 0.2, then you can see it is near about 0.6. 0.6 is the V value. As well, whenever the I is 6, as the I increases, the V is also increasing, and the graph is a linear one. Okay, so that is why we have told like that, because what to say, the relation between the V and I is linear. Okay, I think you have understood the meaning of that one from the graph. Okay, now let us come to the next slide. Now let us discuss about the resistance. So we have seen that V by I is a constant, and that is known as the resistance. So what is resistance actually? This is actually it's a property of the conductor to resist or to what to say, the resistance of a conductor is the barrier for the flow of the current. Okay, actually it resists the flow of the charge, reduce the flow of the charge. Getting or not? The SI unit of resistance is ohm, and is represented by the Greek letter omega. Actually this is the Greek letter, and its name is omega. So resistance is actually the property of the conductor which reduces the flow of the charge through it. Flow of charge means the flow of current through it. Okay, so now let us come to the definition for 1 ohm resistance. What is the definition for 1 ohm resistance? If the potential difference across the two ends of the conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohm. Okay, we know that R is equal to V by I. If the V value is 1 ohm and I value is 1 ampere, then the resistance of that conductor is 1 ohm. Okay, that means if the potential difference across the, if you are applying a potential difference across the conductor as 1 volt, and if we are measuring the current through it, if it is 1 ampere, then we can say the resistance of that conductor is 1 ohm, V by I. 1 volt divided by 1 ampere, that is actually 1 ohm. So we can represent the unit of ohm as volt per ampere. Are you getting or not? Ohm as, we can represent the resistance, the SI unit of resistance, as in terms of V and A, that is the volt and ampere, as V by A. V by A is actually is equal to ohm. Okay, now let us come to the next slide. Okay, the relation between resistance and current. So you know that V by I is equal to R, then you can see, or we can represent I, or we can equate it in such a way, I is equal to V by R. Okay, as V is equal to sorry, R is equal to V by I will be is equal to V by R. That means the current through a resistor is inversely proportional to its resistance, isn't it? It means the resistance and current are inversely proportional to each other. That means if the value of current is increasing by 2 times, then the resistance value will decrease by 2 times, isn't it? Okay, if the resistance is doubled, the current gets halved. Okay, that means if the resistance is getting increased by 2 times, 2R, if the resistance value, if it is getting 2R, then the I will become I by 2. Okay, are you getting or not? It means suppose I is equal to V by R is the equation. Suppose if you are increasing the current value, sorry, the resistance value as 2R, then the new current value will be is equal to V by R divided by 2. That means the earlier one I was equal to V by R. Now when you are increasing the current resistance value by 2 times or doubling the resistance value, then I will become, the new I will become I divided by 2. I is equal to I by 2, that is V by R by 2. Okay, so the component used to regulate the current without changing the voltage source is called variable resistance. So when we have discussed the portion of the symbols of the electrical equipments, we have discussed about the variable resistances, isn't it? So now actually the function of that variable resistances is that to regulate the flow of current through the electrical circuit without disturbing the voltage source. We don't want to change the voltage sources or the potential across the voltage source, we don't want to change, and without changing that one we can regulate the current with the help of the variable resistors. And in some most of the circuits we are using the rheostats as the variable resistor for regulating the value of current through that circuit. You have to remember that term rheostat. Function of rheostat is to regulate the flow of current through the electrical circuit without changing the potential across the voltage source or potential from the voltage source. Okay, I think you are clear with this portion. Now the factors on which the resistance of a conductor depends. Actually the resistance of the conductor depends on majorly on 3 factors. The first one is the length of the conductor, the second one is actually the cross sectional area of the conductor, and the third one the nature of the material. Okay, so the first of all, the resistance is directly proportional to the length of the conductor. That means if you are increasing the length of the conductor, then the resistance value will also increase. Okay, if you are increasing the length of the conductor, then the resistance will also increase along with that proportionally. Okay, suppose if you are doubling the length, then the resistance value also will double. Okay, will become doubled. Okay, now let us come to the cross sectional area. So L is directly proportional to R, but the cross sectional area is actually inversely proportional to the R proportional to 1 by A. Okay, that means if you are increasing or doubling the area, then the resistance value will be get half. Okay, if you are increasing the area, then resistance value, the cross sectional area. Okay, if you are increasing the cross sectional area, then the resistance value will become decreasing or decreased. Okay, now that means R proportional to L and R proportional to A. As combinedly we can say R proportional to L divided by A. So it is the proportional in between this relation. That means we are using the proportional relation over there. So if you want to make this one as an equation, then you have to introduce one proportionality constant. Okay, so proportionality constant you have to introduce, and that one is rho, and it is known as the resistivity of that conductor. So R proportional to L by A become an equation as R is equal to rho into L by A. Okay, R is equal to rho into L by A, where rho is the resistivity of the conductor. Actually the rho depends upon the nature of that conductor. Okay, whichever the material is using, and on depending on that material, the rho value we have to decide. Okay, now let us come to, okay, so rho is the resistivity of the material of the conductor, and the SI unit of resistivity is actually ohm meter. SI unit of our resistance is ohm, and the SI unit of resistivity is actually ohm meter. Actually the reason of that unit is, actually if you are writing, we know that R is equal to rho into L by A, so rho will be is equal to R into A by L. Okay, so where R, the unit of R is ohm, and area, you know that actually pi r square will be there, cross sectional area. So that means we can say in if you are taking that unit, it will be meter square, isn't it? The area will be meter square divided by unit of L is meter, so meter square divided by meter will be meter, m square by m. So that's why the SI unit of resistivity is given as ohm meter. Now in the case of the alloys or metals, so we know that metals and alloys are conductors. Okay, so the resistivity value of the conductors, or we can say the metals or alloys, are near about 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. It's very less actually as well. So that is why they are becoming the good conductors. The resistivity value is very less. So but in the case of the insulators like rubber, glass, or such kind of materials, you know that here the value it is given, the resistivity value is in between 10 to the power 12 to 10 to the power 17 ohm meter. It's a huge value. That's why they cannot conduct electricity. Okay, the resistivity value is too high for the insulators like rubber and glass. So that's the reason why they cannot conduct the electricity, because the resistivity, if the resistivity increases, the conductivity decreases, or we can say the flow of current will be get reduced. So both the resistance and resistivity of the material vary with the temperature. So both the resistance and resistivity are depending upon the temperature. Okay, suppose the temperature varies, then the resistance and resistivity will vary. In the case of conductors, if the temperature increases, then the resistance will increase. Okay, the resistance will increase as the temperature increases in the case of conductor. Now let us come to the example 12.3. Actually all these examples are using the relation R is equal to V by I. In the first case, how much current will, you have to find out the current value. V and R values are given. Okay, so the first one 220 volt and 1200 ohm. So you have to substitute the values in the V is equal to, so R is equal to V by I. So V and R values are given, so I is equal to V by R. You have to that equation, you have to form that equation in the form of I is equal to V by R. Then substituting the values, then you will get the I value as 0.18 ampere. And the second one, how much current will an electric heater coil draw from 220 volt source if the resistance of the heater coil is 100 ohm. So in both the cases the potential it is 220 volt. The potential it is 220 volt, but sorry 220 volt, and the resistance values are varying. Okay, so suppose if the value of the resistance is varying and the potentiality is still same, the current value will vary. You can see that The potential is same, but the ohm value, the resistance value is different. There are difference in the resistance values. Then you can see the variation in the current value. So for constant voltage, if you are varying the resistance, then the current will vary. Okay, so that's the function of the rheostat in the circuits. We have discussed that one. Now we just go through that other examples also. Example two or three more examples are there. We just go through that examples. Actually, in all the examples, only the relation which we are using is R is equal to V by I. Suppose in some cases R value you have to find, then in some other cases I or V values you have to just substitute the values in the question. Okay, just to try that one as well. Just go through that index questions also. Okay, then, thank you.